Now, the second part describes the identification of basic radical. For the identification of basic radical, there are main two steps. First step involves the identification of ammonium cation, which involves two reactions. One is sodium hydroxide test and another is Nessler reagent test. And secondly, group separation table for other cations may be performed for distinguish of the corresponding cations. Without group separation, we cannot infer or we cannot get idea about the metal ions present in our system. So, for primary concept, we have to test the group separation table for identification of the cations, which types of cations may present in our sample. Rather than we have to perform all the tests which are present in our books. Now we go forward for the test for ammonium cation, that is sodium hydroxide test. For this test, we need a ammonium salt, a solid sodium hydroxide and heating apparatus. At first, we take solid ammonium chloride solution which contain ammonium ion. Then add few amount of solid sodium hydroxide flakes over the salt. Then we have to heat the mixture over the flame. After heating, if a pungent smell of ammonia appears with the white or colorless gas, the evolved colorless gas produces white fume on production of a glass rod dipped in concentrated ammonia, which indicates the presence of the ammonium cation in our salt. Another confirmatory test for the ammonium ion is Nessler's test. Since ammonium ion cannot be detected in the group separation tables, this will be tested or confirmed by this Nessler's test. For this test, we have to prepare salt solution by dissolving it into distilled water. After dissolving the salt in distilled water, add few drops of Nessler reagent into the solution. Formation of brown precipitate confirms the presence of ammonium ion in the solution. Hence, our sample may contain ammonium cation as a basic radical. Now we go for the group separation table by which we can categorize the cations in different groups. If we can perform this test nicely, then we can get a concrete idea about the cation present in our sample. So we have to take these steps very seriously. First of all, we have to test this sample in 6 groups, and 6 groups have different types of group reagent. And for this group test, we need dilute HCl, ammonium hydroxide solution, saturated ammonium carbonate solution, disodium hydrogen phosphate, and a H2S gas. Now we have prepared 6 test solution taking one of each group known sample, which I will show here by using the group reagent. How the group reagent is to treat with this solution I will show in this next session. First of all, I have to say that I have taken only one test solution. For different samples, the color of the precipitate appears may be changed depending upon the sample characteristics. But here I am showing only one samples. First of all, test for group 1 cations. This is the test sample. Add few drops of dilute HCl into the sample solution. If any precipitate occurs, then you have to test for the lead, silver, mercurous ion. Here I am taken the lead salt. Now test for group 2 cations. I have taken a known test sample which belongs to the group 2 cation and acidify this solution adding dilute HCl, then pass H2S gas through the solution. The group reagent is HCl and H2S, that is acidic condition H2S should be passed through the sample solution. Here you can see that black precipitate appears after passing the H2S through the acidic salt solution. If after passing H2S in acidic solution, this types of black precipitate appears, then we have to test for the copper, mercuric ion, bismuth, cadmium, lead, arsenic, tin and antimony cations. These belong to the group 2 cations. Now we have to test for the group 3A cations. For this we have to take the sample solution. For this we have to take the sample solution, add pinch of ammonium chloride into it and dissolve it. Then add few drops of ammonium hydroxide solution. Here we can see a clear precipitate, that is brown precipitate, which indicates the presence of the iron cation. For aluminium it will give the white precipitate, for chromium it will give the green precipitate, and the group reagent is ammonium chloride in presence of ammonium hydroxide. If this type of precipitate occurs using group 3A reagent, then we have to test for the aluminium, iron and chromium cations. Now the treatment of the solution with group 3B reagent. The group 3B reagent is ammonium chloride, ammonium hydroxide and H2S. For this we have to take pinch of ammonium chloride into the sample solution, then add few drops of ammonium hydroxide into it. Here we can see that no precipitation occurs. Now, after adding ammonium hydroxide and ammonium chloride, we pass H2S over the solution. Here we can see white precipitation occurs. If there manganese may be present, then the color should be flesh color. For nickel and cobalt, it will give black precipitation. These types of precipitation occurs using group 3B reagent. Then we have to perform the test for zinc, manganese, nickel and cobalt. Now we will treat the test solution with group 4 reagent. Now for this we have to take the test solution, add pinch of ammonium chloride, then add few drops of ammonium hydroxide. Here you can see no precipitation has occurred. Now add ammonium carbonate, that will be saturated ammonium carbonate, into the solution, and here we can see white precipitation occurs. If this type of precipitation occurs using group 4 reagent, that is ammonium chloride, ammonium hydroxide followed by saturated ammonium carbonate, then we have to perform the test for barium, calcium and strontium. If group 4 precipitate is identified, then perform the confirmatory test for magnesium, and there is no special group reagent for potassium, ammonium, sodium, and they must be identified by the individual confirmatory test. Now I have taken the magnesium ion for presentation. For magnesium ion, use pinch of ammonium chloride, then add few drops of ammonium hydroxide. We can see clear solution. Then add disodium hydrogen phosphate to it. White gelatinous precipitate appears, which indicates the presence of magnesium ion in our test solution. After performing the 5 group reagent, we will test for the cations for which the group precipitate has been formed. Hence, since we have group 1 precipitate present in our sample, and by other 5 precipitate remains absent, then we have to test for the only group 1 cations, not for the all basic cations. If we have group 3B precipitate, then we have to test for the group 3B cations, not for 1, 2, 3A, 4 or 5. Like this, we have chosen some basic cations for our confirmative test. Here we will show some of the selected cations, known reactions taking known samples. That will help us to detect the confirmatory reaction for cations. Now we go for the confirmatory test for some known samples. First of all, test for lead cation. This will go through 2 tests. First is potassium iodide test, and for this test we need potassium iodide and sample solution. And for the other test, that is potassium chromate test, potassium chromate, dilute H2SO, dilute acetic acid, and dilute HNO3. We have prepared the sample solution and taken in a two part. For the first part, we take the first part in a test tube and add few drops of potassium iodide into it. Here you can see that yellow precipitate appears. This confirms the presence of lead ion, and this precipitate is soluble in hot water. That is, when we heat this solution, when we keep on heating on water bath, we can see that the precipitate is dissolved in hot water. That is, we can see that the precipitate, yellow precipitate, which was formed after addition of Ki, is completely soluble in hot water. This confirms the presence of lead cation in our sample. This is completely soluble in our hot solution. For another confirmatory test of lead, we will perform the potassium chromate test. For this, the another part of the test solution, we add few drops of potassium chromate solution. Here also we can see yellow precipitate forms, which when divided into two parts for the solubility check. In one part, we will add dilute nitric acid, and we can see that the yellow precipitate is soluble in dilute nitric acid, and the salt solution precipitate becomes clear. In dilute nitric acid, the precipitate is soluble. In the another part, we will add dilute acetic acid, which cannot dissolve the precipitate into acetic acid. Here we can see that the precipitate is soluble in dilute nitric acid, but it is insoluble in dilute acetic acid. It confirms the presence of lead ion in our sample. Now we will perform the confirmatory test for copper, and there is two types of test. One is ammonium hydroxide test and second is potassium ferrocyanide test. For this reaction, we need test solution, potassium ferrocyanide solution, dilute ammonium hydroxide solution. Now we have prepared the test solution with the copper ion and divided it into two parts. For the first test, that is ammonium hydroxide test, we have to take the first sample solution, add 1 or 2 drops of ammonium hydroxide into it. Here we can see that pale blue precipitation occurs. Here you clearly see that pale blue precipitation occurs. After addition of excess of ammonium hydroxide, the pale blue precipitation turns to clear blue solution after dissolving in it. It confirms the presence of copper ion in our solution. Another test is potassium ferrocyanide test. For this, we will take the second part of the solution and add 1 or 2 drops of potassium ferrocyanide solution into it. Here we can see that formation of chocolate brown color precipitation occurs, which confirms the presence of copper ion in our sample. Now we will perform the confirmatory test for aluminium, that is Allegiant S test. For this test, we will require test solution, a blank test tube which will compare with the blank test, Allegiant S solution, sodium hydroxide flakes and dilute acetic acid. Now for this test, we will take the sample solution, and on the other hand we will take distilled water for the blank test. Here I am putting the sample solution on my left hand, and on my right hand I am putting the blank test tube or test tube filled with the distilled water. Now add sodium hydroxide flakes to make it proper basic. Now we have dissolved the two solution. On my left hand is aluminium solution and right hand is distilled water filled with the sodium hydroxide flakes. Now add few drops of Allegiant S solution into the solution. Here you can see that both color is same, that is violet. That color appears for the Allegiant S reagent. Now after adding the Allegiant S reagent, we will add acetic acid solution until the color disappears. After addition of acetic acid, the violet color turns red. Let's see with the blank test. Similarly, we are adding acetic acid. Here we can clearly see the changes with the aluminium and with the blank test. Here in my left hand it is the final color of the aluminium solution, and in the right hand here is the color with the distilled water without aluminium ion. The final color of the solution is red in case of aluminium, but in case of blank test without any aluminium ion, the test color is yellow. Hence, red color of the sample solution confirms the presence of the aluminium. Now we will test for the confirmatory test of ferric or ferrous ion. Here I have taken two test solutions one of which contain ferrous ion and one of which contain ferric ion. Let's see with the ammonium hydroxide test what happens. We can distinguish between these two, which is ferrous and which is ferric ion. Now for this test we have to take the sample solution and add few drops of ammonium hydroxide into it. The brown precipitate indicates the presence of ferric ion, that is Fe+3, and in case of ferrous ion we will get dark green or pale green precipitate using ammonium hydroxide. Here we can see the color changes to dirty green color. Now with treatment of the test solution with ammonium hydroxide, we will get brown precipitate for the ferric ion, and for the ferrous ion we get dirty green precipitate. By this test we can distinguish between the ferric or ferrous ion. Another confirmatory test for ferric or ferrous ion is potassium ferrocyanide test. For this test we have to take sample solution and add few drops of potassium ferrocyanide solution to it. Prussian blue color precipitate confirms the presence of ferric ion in our solution. Let's see what happens with the ferrous ion using this reagent. With ferrous ion we can also see green or pale blue precipitate which is distinct different from the ferric ion. My left hand side shows the test for ferric ion and this test shows for the ferrous ion. Here two types of color is different, but the color is bluish in nature. Hence by these two tests we can distinguish between the ferrous or ferric ion present in our solution. First of all is ammonium hydroxide test, by which ferric ion gives brown precipitate and ferrous ion gives green precipitate, dirty green precipitate. By using potassium ferrocyanide test, ferric ion gives dark green precipitate or dark blue precipitate, but in case of ferrous ion we will get this type of blue or bluish green precipitate. Now we will go for confirmative test of manganese ion. For this test we need sample, distilled water, sodium bismutate and dilute HNO3. To go for this reaction, at first dissolve the sample into distilled water. After dissolving the sample into distilled water, add few drops of dilute HNO3. After that, add solid sodium bismutate to it. After that, add pinch of solid sodium bismutate into it. The color changes to pink to violet. The formation of pink or violet coloration on addition of the sodium bismutate confirms the presence of manganese ion in our solution. Hence our salt may contains manganese ion. Now we go for the test of zinc ion, that is confirmatory test by hydrogen sulfide reaction. Now for this reaction we take the sample and dissolve it in distilled water. After dissolving the sample in distilled water, we will add NOH to it. After addition of slight NOH, their formation of gelatinous precipitation occurs. After addition of excess of sodium hydroxide solution, the precipitate dissolves. Then we will acidify the solution adding acetic acid. After acidifying the solution using acetic acid, pass H2S gas through it. Here we can see that white precipitation occurs. The formation of white precipitation on passing H2S gas in acidic condition confirms the presence of zinc ion in our sample. Here one thing is notable, that only zinc sulfide is white in nature, and this is the confirmatory test for zinc. Now the confirmatory test for cobalt ion, that is potassium nitrate test. For this test we require sample solution, potassium nitrate, which may be prepared freshly, and dilute acetic acid solution. For this reaction, at first we have to prepare sample solution. For this reaction, at first dissolve the sample in distilled water, then add few drops of acetic acid into it to make it acidify. Then add freshly prepared potassium nitrate, that is KNO2 solution, into it. And keep it for few minutes. The color will slowly changes to yellow, which will confirm the presence of cobalt ion. Here you can easily see the color changes. After a few minutes, the color of the sample solution becomes yellow. This formation of the yellow coloration confirms the presence of cobalt ion in our solution. Now we will go for the test for calcium ion, that is ammonium oxalate test. For this reaction we need sample solution, glacial acylic acid and ammonium oxalate solution. To perform this reaction we have to take the sample solution, then add few drops of ammonium oxalate to it. Here you can see formation of white precipitate occurs, which is insoluble in concentrated acetic acid, that is glacial acetic acid, confirms the presence of calcium ion in our solution. Hence, the formation of the white precipitate on addition of the ammonium oxalate, which is insoluble in concentrated acetic acid, confirms the presence of calcium ion. Now we will perform the confirmatory test for magnesium, that is sodium hydroxide test. For this test we need sample solution and sodium hydroxide solution. Now for this reaction we have to dissolve this sample into distilled water. After dissolving the sample into distilled water, add few drops of sodium hydroxide solution to it. Formation of white precipitate. Here we can see white precipitate is formed. Formation of white precipitate confirms the presence of magnesium. This precipitate is soluble in solution. Here you can see the white precipitate is clearly soluble in ammonium chloride solution. This confirms the presence of magnesium in our state solution. Now we will test for the confirmatory test of chromium, that is lead acid test. For this we require sample H2O2, lead acetate solution, NOH solution. For the lead acetate test, we will dissolve the sample solution in distilled water. Then add few drops of sodium hydroxide to it. At first precipitation occurs, then add excess of NOH to dissolve the precipitate. Then add few drops of H2O2 solution. Heat the mixture until bubbling occurs. During this heating, the chromium plus 3 is oxidized to chromate ion, which will be tested using lead acetate solution. After heating, the reaction color changes to yellow, which means the oxidation has completed. Now, acidify the reaction mixture using acetic acid. Then add lead acetate solution into it. Formation of yellow precipitate confirms the presence of chromium plus 3 in our solution. Reading this reaction course, the chromium plus 3 is oxidized to chromate ion using sodium hydroxide and peroxide and heat, and this chromate ion is tested using lead acetate solution. Now we will go for the test of nickel, that is dimethyl glyoxime test. For this test we require sample solution, dimethyl glyoxime and ammonium hydroxide solution. To proceed for the reaction, at first take the sample and add distilled water to dissolve it. After dissolving it in distilled water, made it alkaline using ammonium hydroxide. During alkalization, the color changes to blue. After that, to this alkaline solution, add few drops of dimethyl glyoxime solution. Formation of rose red color or bright pink red color indicates the presence of nickel in our solution. This type of rose red color appears for nickel DMG complex. Now we will perform the confirmatory test for stannous ion, that is Sn+2, which is mercuric iodide test. For this test we require dilute HCl and 0.2 molar mercuric chloride solution. Then to proceed for the reaction, at first take sample solution which contained Sn+2, then add few drops of HCl into it. After acidifying the reaction solution, add 0.2 molar HgCl2 solution to it. White or grey-white precipitate confirms the presence of Sn+2 in our solution. This reaction also used for the detection of mercuric ion, that is Hg+2 ion. On that side, the known sample will be the Sn+2. For this reaction, we will add for the detection of the mercuric ion, we will add acidic solution of stannous chloride into the sample solution. Here also we can see that formation of the grey or white precipitate appears. So this reaction is beneficial for both way, for the detection of stannous ion as well as for the detection of the mercurous ion. So this reaction is beneficial for both of the cation, that is Sn+2 ion, as well as mercuric ion, that is Hg+2 ions, and this reaction can be used for confirmative test for mercurous and Sn+2 ions. So dear students, here we have seen how the basic as well as acidic component of the salt can be determined stepwise using chemical procedure. Hence, by this above procedure, we can distinguish a given unknown salt by their cationic and anionic part. And this lecture will be helpful for your laboratory classes that will be held during the LCS practicum, and wish you a best of luck. Thank you.